Hi there, and welcome to today's class. For today's class, we'll be looking at the solution to experiment 1.1 in the organic chemistry practical manual. So this experiment 1.1 is for the reaction of hydrocarbons. Basically, you're testing for the basic hydrocarbons such as the alkanes, the alkenes, the alkynes, and the aromatic, which is majorly benzene in this case. So for the procedure, you'll be reacting each of them with bromine, reacting them with potassium permanganate, and then reacting them with cuprous chloride. All right, so you can pause this video and read this if you want to, but we're going straight to answering the questions. All right, questions here. The first question here says, one says, which of the four samples reacted with bromine? Okay, now for this I'm not giving any answer because it will always change depending on the year. All right, for some years they could use, it could be sample A and B. For another year it could be sample B and C. For another year it could be sample A and D, just like that. So I'm not giving any year. Okay, so when you do the experiment, check which of them reacted. But then one thing to notice this, majorly probably like two samples will react because normally the alkynes and the alkenes. All right, the alkenes, let me write that one down. So note that alkenes and alkynes do react with bromine. All right, so if that's true, if they say which of these four samples reacted, we expect like probably two of them should react. Okay, but this should come from your own experiment, so I'm not giving any definite answer for that. So you check your group work and then get down for yourself. All right, next up, the number two says, which of the samples had a sweet aroma? Again, this sample will change every year. All right, so I won't give you a definite answer so that by next year, someone else does not come here and then copy this thing. No, it will change. All right, so from what you did in your group, which of them had this sweet smell when you try to perceive it? All right, if it was sample A for you, write A. If it was B, write B. If it was C, write C. If it was D, also write D. So that's how this is done. Number three says each of the samples that did not react, right? Of the samples that did not react, which do you think is aromatic? Give reasons for your answer. Now, for this one here, what you should note is that for number three here, whatever answer you use as number two should be your number three, all right? They're the same thing. Why? They said, which do you think is aromatic? Give reason for your answer, all right? Aromatic or the aromatic compounds, the term aromatic comes from the word aroma, all right, which means they have what there, a sweet characteristic aroma. So of the samples that did not react, which do you think is aromatic? So let's say number two, you had sample A. Now this is just an illustration, right? So whichever thing you have here should also reflect here. So let's say number two, you had sample A, for instance. Number three, your answer will still be the same thing, that's sample A. They said you should give reasons, and the answer is simple. It's because of what? The aromat it's aromatic. It is aromatic because it has a characteristic sweet smell, or you can say characteristic aroma, whichever one. So that's your answer. So I'm saying number two and number three should be the same thing. Alright? Alright, number four. Number four says write an equation for the reaction of cyclohexene with bromine. Name the product. Alright, so let's write an equation for cyclohexene and bromine. And also we are asked to name the product. So what do we have? So first things first, let's get cyclohexene. Now hex is 6, so 1, okay, excuse me, bring this down. So I'm having 1, 2, 3, 4, 5, 6. Alright, so I have this. Since it's a hexene, that's a double bond to show alkene. So we have this. Alright, so we have this. This one becomes CH. Okay, this becomes CH. This becomes CH2. Right? This becomes CH2. This becomes C. You can say H2C. Still correct? You can also say H2C. That's the correct. Alright, so what I have here is called cyclohexene plus, they said plus bromine. Now note that bromine is actually diatomic, so it becomes Br2, not just Br. Alright, so if these two combine, what do I have? If I combine these two, what will I have? Now what I'll have would look like this. My answer would look like this. All right, so if I combine, so I have this. So if I combine this, what do I have? Come here, you'd have C here, 2, 3, 4, 5, and then 6. So we have this. All right, so let's combine this. Now, this was a single bond here, a single bond here, single bond here, single bond here, single bond here. Now, here's what to note. If I look at this, this was a double bond. When this combined, when this cyclohexene combines with this, the bromine atoms here will displace the double bond, causing a single bond here. So here will be single bonded. Then remember that we have 2 atoms of bromine. Okay, so where I had H here, 1 atom of bromine comes here. Also where I have here, 1 atom of bromine comes here. So I'll have this. So this now becomes the 2 atoms of bromine we had in the reaction. Alright, these other ones maintain themselves. What I mean is if I come here, H2, 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 H2. So I'll just repeat that here. This becomes C, H2, C, H2, C, H2, C, H2. So I have this. Alright, so this becomes the answer. Alright, but before then, let's name the reactants and products. So what I have here is cyclohexane. So I have this as cyclohexane. That's this compound. What I have here is bromine. Of course, this should be in a straight line. So when you're doing yours, it should be in a straight line. Okay. What I mean by straight line is that this bromine should be in the same line with this. That's more like bromine, like this. All right. So they should all be in this straight line. It's much more professional that way. Okay. But because of this, more like a video tutorials, I'll just make it look nice. Okay. So this one here would now be 1,2-dibromo. So this compound here is 1,2 hyphen dibromo cyclohexane. So we're asked to name the compound. The name of the compound there is 1,2-dibromohexane. So that's the solution to question 4. Let's move over to question 5. Alright, so number 5. The next question here says, write an equation for the reaction of phenylethyne with bromine. Alright, so let's get phenylethyne and then bromine. So number 5 solution, phenylethyne. The formula is this. So I have this. Let's get the phenylethyne first. So I have this. I have C, 1, 2, 3, CH. Alright, so what I have here is phenylethyne. Alright, so we decided we should combine this with bromine. So plus, of course, we've said bromine is diatomic, so Br2. And then let's see what our product gives. If we combine these two, the product alright, so what you have here becomes CBr. That's carbon combined with bromine. What you have here becomes CH Br. So I have this. Alright, so this is what my product looks like. My next task will now be to name each of them. Alright, so on naming this, what I have here is actually phenylethyne. This is called phenylethyne. Okay, what I have here is bromine. I've said it should be on the straight line. Alright, so this should rather be somewhere around here instead, so it will look orderly and uniform. Alright, so bromine. My product here is, the name of this product is called phenyl 1,2-dibromoethene. So what I have here becomes, this product is called phenyl 1,2-dibromoethene. Alright, so this is the reaction we were asked to get, this one here. So here's my reaction. Okay. Alright, so number 5 is being sorted out. Let's go to the next question there. Question number 6. Oh, so that's all for number 5. So next up, B. B says, which of the samples reacted with potassium permanganate? Alright. Which of the samples reacted with potassium permanganate? Now when it comes to the sample that reacts with potassium permanganate, it's possible that you can have two different samples. Now usually it's the alkenes and alkynes. Let me write that down. Usually it's the alkenes and alkynes that react with potassium permanganate. So if they ask which of the samples reacted with potassium permanganate, probably you're expecting two samples. Probably sample one sample and then call the other one, right? So we expect like two samples. It could be any of them, right? Maybe A and D or C and B, whichever one there. So just bear in mind that we could expect two samples here as an answer, okay? Or probably even three too, right? Number the B2 says write an equation for the reaction of permanganate with cyclopentene. Now I've said for cases like this, you just have to do the experiment. When you do the experiment, you now see the answer. That's how to get this one here. Or better still, work with your group. Alright. Your group should be able to put heads together and get your answer. 2b says write an equation for the reaction of permanganate with cyclopentene. Name the product. So for this, I'm reacting permanganate, which is of course the short form for potassium permanganate, with cyclopentene. Alright, so let's react this to. We also asked to name the product. So what do we have? Alright, let's look at B2. So that's for B2. So B number 2. The first thing there is potassium permanganate and then cyclopentene. So any of them can come first. So let me start with cyclopentene. For cyclopentene, you have this for your structural formula. You can have alright, so we have this for cyclopentene. You can add this here. Alright, so this is what a cyclopentene looks like. Now combine this with potassium permanganate, it becomes plus potassium permanganate. Usually it acts as a catalyst. Alright, it's usually a catalyst, so it becomes KMNO4. That's your formula for potassium permanganate, KMNO4. So I have this. Alright, so we have this. So the next thing is to find our product. What would the product be? If I combine these two, my product would be this. Alright, so here will be OH. Here will also be OH. Alright, so basically this is what you'd be having. Alright, and next task will now be to name this whole equation. Now what I have here, as we said, is cyclopentene. So I have cyclopentene. What I have here is permanganate, better still potassium permanganate. Please, it should be in a straight line. I'm just trying to conserve space here. Okay, so potassium permanganate. What's the next thing there? This one here. So we have to name the product. What do you call this product? This product here is nothing more than cyclopenta 1,2-diol. Right? This is called cyclopenta 1,2 diol. That's the name of the compound. So please observe the way I use the hyphen and the comma, right? So use the hyphen and comma exactly the way I do them here, all right? Okay, so this is the answer to that question, right? So if I have cyclopentene combining with potassium permanganate, my result gives you, my product becomes cyclopenta 1,2 diol. It's a penta, okay? Penta 1,2 diol. Alright, so I have this. Next up, let's look at the next question. Let's look at 2C. Okay. Okay, this is B2. Alright, this is B2. Let's look at B3. B3 says write an equation for the reaction of permanganate with ethyne. Alright. So permanganate and ethyne, if they combine, what do you have? That's B3. Alright, B3, permanganate and ethyne. So let's look at B3. Permanganate and ethyne. Alright, so first things first, let's get ethyne. So ethyne is simply CH triple bonded to CH. This is ethyne. So if ethyne combines with permanganate, I've said before that permanganate is usually used as a catalyst. So in this case, it becomes KMnO4. So if I react this, what will be my answer? Or what will be my product? My product in this case would be this H single bonded to oxygen, single bonded to carbon, double bonded upwards to oxygen, single bonded to carbon, double bonded upwards to oxygen. I'm having oxygen here, and then I have hydrogen. So this becomes my compound. All right, that will be my product. We're asked to name this, so you can start with this one first. Of course, as we know, this is ethyne. Right, this is ethyne. Okay, this one here is potassium permanganate. All right, my product. What's the product here? What's the name of this product? This product here is called oxalic acid. This is called oxalic acid. Right, an alternative name is called dicarboxylic acid. Right, so call it dicarboxylic acid. All right, so that's my answer for this question. Let's look at the next question there. All right, look at B4 here. The next question, B4. B4 says write an equation for the reaction of permanganate with ethane. All right, so it's now permanganate and ethane. So that's B4, permanganate and ethane. Let's write a reaction for that. What do we have? So I'll just call this B4. B4 here. So I'm having ethane, I'm having permanganate. If they combine, what do they have there? So first things first, ethane. Ethane is this H3C single bonded to C, then H3. That's ethane. Ethane combines with, again, permanganate as a catalyst. So I'm having KMnO4. If they combine, what do you observe? There will be no reaction. That's one thing to note, okay? So no reaction. All right, so to note that for this, there is no reaction, okay? So what to note is this. Note that potassium permanganate does not react with ethane or other alkanes. Now this is because they are saturated or not readily reactive. So the answer is no reaction. Alright, so that's how we get through B. I think we're done with this. Next up, our next question here should be, alright, the C part. So our next question here should be the C part. Let's get the C part done. All right, so let's continue with this. So C says which of the samples gives a precipitate with cuprous chloride solution? Again, your answer would be from your experiment, okay? This answer would change depending on the year, so I won't give you a definite answer. So when you do the experiment, which of them did react? I think only one will react, because usually only the alkynes react with cuprous chloride. So probably we should expect just one answer here. So when you do the experiment, which of them reacted? Was it sample A? Was it sample B? Was it sample C? Or was it sample D? So write your answer here. Next up, C2 says, write an equation for the reaction of ammonical silver nitrate with phenylethyne. What is the role of ammonia in the reaction? Alright, let's get C2 done. Alright, so C2. Alright, so for C2, we're asked to write an equation for the reaction of ammonical silver nitrate with phenylethyne. Alright, so first things first, silver nitrate. So you have silver nitrate here, which is AgNO3. That's silver nitrate combining with phenylethyne. Let's draw the structure for phenylethyne. Okay, so we have this. Next up, we'll have this, this, this. Okay, so my structure I will have here as being C. Right, then you have H here. All right, so what we have here is phenylethyne. So when they combine, what do we get? They'll combine. So let's get our product. By the way, for this reaction here, you would need ammonia here as a catalyst and also as an oxidizing agent. Okay, so what's our result? What's our product? For this, our product would look like this. All right, so what we have here is C triple bonded to this. All right, then this would have, we still be having plus, so plus, be having ammonium nitrate, that's NH4 NO3. So be having this, that's ammonium nitrate. All right, so basically this is what my reaction would look like. So let's name these ones here. So starting from this, the name for this is silver nitrate. So I have silver nitrate. For this, I have phenylethyne. Phenylethyne. Okay, moving on. For my product here, of course, this is ammonia. If you want to, this is ammonia. This is ammonia. Okay, so for my products here, what I have here is phenyl. This is called phenyl silver acetylide. It gives me phenyl silver acetylide. And finally, my last product here is ammonium nitrate. I'm having ammonium nitrate. Alright, so I have this. Alright, so this is my complete equation of the reaction. Zoom out a bit. Okay, zoom out a bit more. Alright, so this is what I have here. So silver nitrate combining with phenylethine using ammonia as a catalyst, also an oxidizing agent, gives you phenyl silver acetylide and ammonium nitrate as your products. Okay, now also the question says, what is the function of ammonia in this reaction? All right, so what's the function of ammonia? It's ammonia here. What's the function? Now here's your answer. So here's what to note. Here's what your answer should look like. So ammonia is used as an oxidizing agent. All right, ammonia is used as an oxidizing agent. All right, so we have this. So that's your answer. Okay, ammonia is used as an oxidizing agent. That's your answer. All right, so what's the next thing there? So aside these two, there's also something else you could write. You could also say ammonia catalyzes the reaction by serving as a base to subtract acidic hydrogen from alkyne. Okay, that also works too. All right, so next up, let's move on to the next thing there. The next question there, that's C3. Let's see what C3 is. C3 says, write an equation for the reaction of cuprous chloride with 1-phenylpropyne. Alright, 1-phenylpropyne. So what do we have? Let's get C3 done. Alright, so C3. So first things first, cuprous chloride, that's CuCl. This man combines with, they said combine this man here with 1-phenylpropyne. So let's get 1-phenylpropyne. So CH2, and I have C triple bonded to CH. So I have this. Alright, so this is my 1-phenylpropyne formula. Again, for this, I'll be using ammonia as a catalyst. So I would have ammonia here, NH3. I'll have this. So let's get that product. What would the product look like? So first things first, I'm having this one here. Excuse me. Having this single bonded to C. 1, 2, 3. I have C. Okay. I have single bond here to copper. So I have C2. Alright, so I have this. Then plus, I'll also be left with another reactant here, which is ammonium chloride. That's NH4Cl. NH4Cl. Alright, so this is what I have. Let's try to name each of the compounds I have here. So starting with this, what I have here is cuprous chloride. Cuprous chloride. Okay. What I have here is 1-phenylpropyne. Okay. Next up, of course, this ammonia. Okay. Moving on, what I have here is 1-phenyl copper acetylide. Okay. 1-phenyl copper acetylide. That's a major product. And then you have a minor product. The minor product here is ammonium chloride. All right, so I have this. So basically this is the answer to this question. So all right, so just so you can see this is what my answer looks like, right? So cuprous chloride combining with 1-phenylpropine using ammonia as a catalyst to yield 1-phenyl copper acetylide. This should have been closer, but okay. 1-phenyl copper acetylide plus ammonium chloride as your result. Okay, so I have this. All right, so that's the answer to 3C. Next up, let's look at that's all about 3C. Now, our final question here is 3D. 3D says from your answers to the question above, indicate the hydrocarbon classes for sample A, B, C, and D, given reasons. That means sample A, tell us if it's an alkane, an alkene, an alkyne, or a benzene. That's an aromatic. Same thing with sample B, sample C, sample D. So they are telling you that out of sample A, B, C, D, identify which of them is an alkane, which is an alkene, which is an alkyne, and which of them is an aromatic, which is benzene, of course. And they say you should give reasons for this. All right, we'll treat this one here in our next video. All right, so please, if you enjoyed this video, make sure you like the video. Okay, also leave a comment. Okay, so before we release part 2, tell us sample A, B, C, D, which of them do you think is alkane, alkene, alkyne, and aromatic? Right, leave your answer in the comment section and we'll get to it. Okay, next up, don't forget to share this video to your friends so that they can also learn. And finally, subscribe to this channel if it's your first time. Okay, thank you and see you in our next class.